In today's class we are planning to discuss about loaders. In the last few classes we have discussed about the different assemblers, and also different type of assemblers: single pass, two pass, and a multi-pass assembler. The next the output of assembler is actually we know that assume that this is our assembler and input will be source program or assembly language program, and the output will be, in our case, output will be object file. So this is about the assembler. Then next is for execution. We have to load this object file content. This is actually stored in a secondary storage. In our example case, this file is character file or text file. For simplicity, we have made the object file format as text file. So we need to for execution, this text file, this is actually present on hard disk or some storage like that, secondary storage. So and assume that this is our RAM or memory. So for execution purpose, this program has to be loaded into memory, and for that purpose we need another software, system software called loader software. So loader is responsible for loading this object program byte by byte from the secondary storage into our primary memory or RAM. So that is the basic principle of a loader. Then we can go into detail loaders and linkers, then basic loader functions. So three processes to run an object program. First one is loading. Loading means brings object program into memory. Relocation, another process is relocation, modifies the object program so that it can be loaded at an address different from the location originally specified. Then another process is linking process, combines two or more separate programs and supplies information needed to allow cross references. Another concept is loader and linker. Maybe single system program. Loader performs the loading and relocation process. Linker will perform the linking. So loader and linker are two system software. Sometimes that may be a single system software called a linking loader. Then we can consider a very basic loader, or called we'll call as absolute loader. In that case, no linking and relocation needed. Only we need to bring the object program into memory, to a specified memory location. Always that will be loaded there. So there is no linking and relocation. So records in the object program are we already know that header record, text record, and end record. These are the records in the object program. Header record, check the header record for program name, starting address. So this absolute loader will check the header record for program name, starting address, and length. അപ്പോൾ അതിൻ്റെ ഹെഡർ റെക്കോർഡ് നോക്കിക്കഴിഞ്ഞാൽ അതിന് അബ്സല്യൂട്ട് ലോഡറിന് മനസ്സിലാവും എവിടെയാണ് ഈ പ്രോഗ്രാം ലോഡ് ചെയ്യേണ്ടത്. ദെൻ സിമിലർലി start, okay, what is the program name, then length, how much or how many bytes are required for storing this program. If that much amount of memory is available within the this memory, then only it will be loaded. Then text record, this brings the object program contained in the text record to the indicated address. End record transfers control to the address specified in the end record. Okay. So this is an example object file that we have considered earlier. In this object file we will have header record and a number of text record and end record. So header record will start with h, then program name, starting address, then this is the okay, this is our program name, and this is our the starting address, and this one is our length. Okay, then these are the text records. So this corresponds to the object program. This corresponds to the assembly language program. This one, this one, okay, corresponding to this. This was our simple program. SIC programs to read records from an input device and to write them into an output device. So this was our machine code 141 this program. Okay, the object for this object file corresponds to that program. And how the loader will use this object file or the header and text records, header text and end records for during loading purpose. Then this will read each of these records. Initially read the header record, from that it will get the name, starting address and length, and if that memory is available, then the loader will start loading. For example, from 1000 onwards, assume that this is 0, then 16 bytes are there in this direction. For simplicity we have considered like this. This is 0 0 0. This first one represents okay, this represents, first one represents 0 0 0, next 0 1 0 2, like that. Or we can say that this is the 0 1 2 3 4 5 6 7 8 9 10 11, or in the case of hexadecimal, if you are writing, this will be A B C D E and F, 4 byte 4 byte 4 byte 4 byte, like that. So after that this will become 0 0 1 0. Similarly here also 1 1 1 2 1 3 1 4 1 5 1 7, like that. That is the memory locations. So this program, by looking into this object file, first text record is taken by the loader. So the starting address is 1000, hexadecimal 1000. So that will be prepared. Okay, 1000 is prepared now. This is the 1000 location. Then how many number of records? 1E records are there. Then these are the actual 1E bytes. 1E bytes are there, and these are the actual location, actual object code. So 141033. So that is loaded there. 141033, 3 byte. Then next is 482039. 482039. Okay. Then next is 001036. 00 so 0 0 1 0 3 6. So that will be loaded here 0 0 1 0 3 6. And next one is 281030. So 281030 like that. So all them will be loaded. Finally okay, up to this, assume that up to this 0 0 0. So up to this, that is loaded from here up to this one, this portion. Okay, up to this we have loaded. Then consider the next text record. Next record starting address is 2039. Not just immediate address. Okay, after reaching here 10 30 31 32 33, there is no record now. So next record is starting from 2039. That is this one. 2039 is this one. So from here onwards, the next objects codes will be stored. They are okay, this one 041030, 041030, then 01030. Okay, next one is this one. So that will be here like that up to this one. So there is a gap between these two. This gap is actually the memory reserved for some variables, because our program was this one that contains some variables, some okay, return address reserved 1, then length reserved 1, buffer area reserved byte 4k locations. So that gap is corresponding to these variables for reserving memory for this variable. That is actually starting from 1033. That is here. That is why from 1033 onwards there is a gap within the memory. There is no object code is loaded, and there is no text record corresponding to this one. That is why there is a gap. So this area will be used for reserving memory for variables. Okay. So anyhow, by reading these text records and these records within this object file, this loader will load that into memory. Sorry. So this is the algorithm, simple algorithm for an absolute loader. So begin, read header record, verify the program name and length, read first text record, then while record type not equal to end, begin, if object code is in character form, convert it into internal representation. Just leave that now, we can explain that later. Then move object code to specified location in memory. Object code location move cheya. Then read next object program record. Then do the same thing. Move object code to specified location in memory. Read next one until end E record is reached. When E record is reached, jump to the address specified in the end record and start execution. So in the E record there will be starting address, or execution starting address. Whenever the C is reached, the loader will that is, the loading is now complete, and the control will goes to 1000 or jump to this 1000 location, and execution will start from there. That's about the absolute loader. Then what is this portion? And we already assumed that for simplicity our object file is in text as is stored as a text file. So each character represents 1 byte of storage, but actually these two forms a byte in hexadecimal, but only because of storing this as text file, each character requires 1 byte. So what we have to do, we have to read 2 characters, then convert them into hexadecimal form and then load into memory. That is the mentioned here. If object code is in character form, convert into internal representation or binary representation, and then move that object code to specified location in memory. Most of the machines store object codes in binary. In actual case, the object code will be stored as binary form, so there is no need for this one. But in our case, for simplicity, we have stored our object file as a text format or character format for readability, for readability purpose. If you are storing this object file in binary form, that is not good for reading. Then so object code can be represented in either character form or text file, just like us, or binary form. If you are storing in character form, each byte of assembled code is given using its hexadecimal representation in character form, easy to read by human being. And that is our case, followed by our example. And binary form, we already explained that each byte of object code is stored in a single byte itself. Most machines stores object programs in binary form. Okay. So this is about the absolute loader. Then next concept we have to discuss about is a bootstrap loader. Bootstrap loader. So what is a bootstrap loader? അപ്പോൾ നമ്മൾ ഇതുവരെ പറഞ്ഞ അബ്സല്യൂട്ട് ലോഡറാണ്. അപ്പോൾ അബ്സല്യൂട്ട് ലോഡറിൻ്റെ ഒരു എക്സാമ്പിൾ, ഒരു ആപ്ലിക്കേഷനാണ്, നമുക്ക് അബ്സല്യൂട്ട് ലോഡർ യൂസ് ചെയ്യാൻ പറ്റുന്ന ഒരു കേസാണ് ഇത് ബൂട്ട്സ്ട്രാപ്പ് ലോഡർ എന്ന് പറയുന്നത്. അപ്പോൾ നമ്മൾ അസ്യൂം ചെയ്യുകയാണ്, നമ്മുടെ SICയുടെ കേസിലാണെങ്കിലും നമുക്ക് എന്താണ്, ഒരു ഓപ്പറേറ്റിംഗ് സിസ്റ്റം വേണം. അപ്പോൾ ഈ ഓപ്പറേറ്റിംഗ് സിസ്റ്റത്തിന് എന്ത് ചെയ്യണം, മെമ്മറിക്കകത്തോട്ട് ലോഡ് ചെയ്യണം. അപ്പോൾ ഫസ്റ്റ് എങ്ങനെ അതിനെ ലോഡ് ചെയ്യും? ഇനീഷ്യലി മെമ്മറിക്കകത്തൊന്നും ഉണ്ടാവില്ല. അപ്പോൾ ഫസ്റ്റ് ടൈം നമുക്ക് ഒരു പ്രോഗ്രാമിനെ എങ്ങനെ മെമ്മറിയിലോട്ട് ലോഡ് ചെയ്യും, അല്ലെങ്കിൽ ഓപ്പറേറ്റിംഗ് സിസ്റ്റത്തിനെ എങ്ങനെ ലോഡ് ചെയ്യും. അപ്പോൾ അതിന് വേണ്ടിയുള്ള ഒരു വെരി സ്മോൾ പ്രോഗ്രാമാണ് എന്ത്, ബൂട്ട്സ്ട്രാപ്പ് ലോഡർ എന്ന് പറയുന്നത്. ദിസ് ബൂട്ട്സ്ട്രാപ്പ് ലോഡർ വിൽ നോർമലി റിസൈഡ് ഇൻ റോം ഓർ ബയോസ് ചിപ്പ്. ഇപ്പോൾ സിസ്റ്റം ഓൺ ചെയ്യുമ്പോൾ എന്ത് ചെയ്യും, ബയോസിനകത്ത് ഒരു ചെറിയൊരു പ്രോഗ്രാം ഉണ്ടായിരിക്കും. ആ പ്രോഗ്രാം എന്ത് ചെയ്യും, that will known as bootstrap loader, that will load operating system into memory. Then control will be hand over to operating system. Then further jobs will be controlled by monitored by operating system. So this is our memory. Assume that this is our memory. This bootstrap loader is usually present within ROM or BIOS. Assume that this BIOS ROM is mapped to this location, to this area. BIOS is mapped to the first location of the memory. BIOS ROM. First, the starting location from 0 onwards, BIOS is mapped. ROM is also a primary memory, so that can be directly read by the operating system. Okay. So this bootstrap loader is a very small program that is responsible for loading operating system into our memory. Assume that OS is to be loaded from memory address 80. നമ്മൾ SIC/XCയുടെ കേസിൽ അങ്ങനെ നമ്മൾ അസ്യൂം ചെയ്യാണ്. SIC അല്ലെങ്കിൽ SIC/XCയുടെ കേസിൽ OS is to be loaded from memory location 80. That is always like that. So in this case, for this bootstrap loader can be designed as a variant of absolute loader. കാരണം ഇവിടെ ബൂട്ട്സ്ട്രാപ്പ് ലോഡർ എന്താ ചെയ്യുന്നത്, എപ്പോഴും OSനെ എപ്പോഴും ഇങ്ങോട്ട് തന്നെ ലോഡ് ചെയ്യുക. കാരണം ഫസ്റ്റ് OSന് ഇവിടെ വേറെ ഒന്നും ഉണ്ടാവില്ലല്ലോ, അപ്പോൾ ഇവിടെ ഫ്രീ മെമ്മറി ആയിരിക്കും. അപ്പോൾ അതുകൊണ്ട് ഈ OSനെ ലോഡ് ചെയ്യാൻ വേണ്ടിയിട്ടുള്ള ലോഡർ, ആ ലോഡറിനെ നമുക്കൊരു അബ്സല്യൂട്ട് ലോഡറായിട്ട് ഡിസൈൻ ചെയ്യാൻ പറ്റും. ഓക്കെ. സോ ഇൻ അവർ എക്സാമ്പിൾ, we have to load the operating system into the address, fixed address 80. So when a computer is first turned on or restarted, a special type of absolute loader, bootstrap loader, loads the first program, usually operating system, to be run into memory. SIC bootloader, നമുക്ക് SIC യുടെ കേസിൽ അതെങ്ങനെ നമുക്ക് ഡിസൈൻ ചെയ്യാമെന്ന് നോക്കാം. The bootstrap itself begins at address 0. It loads the operating system starting address x80. അപ്പോൾ ഇങ്ങോട്ടാണ് നമുക്ക് ലോഡ് ചെയ്യേണ്ടത്. No header record or control information. The object code is consecutive bytes from memory, from secondary memory. After load the OS, the control is transferred to the instruction at address 80. അപ്പോൾ നമ്മൾ നോർമലി ഈ ഹാർഡ് ഡിസ്കിലോ അല്ലെങ്കിൽ അങ്ങനെ എന്തെങ്കിലും ഇതിനകത്തുള്ള മാസ്റ്റർ ബൂട്ട് റെക്കോർഡ് എന്ന് പറഞ്ഞിട്ടുള്ള ഒരു സെക്ടറോ അല്ലെങ്കിൽ ഒരു പോർഷൻ ഉണ്ടായിരിക്കും. ഈ ബൂട്ട്സ്ട്രാപ്പ് ലോഡർ എന്ത് ചെയ്യും? ദാറ്റ് വിൽ ലോഡ് code, that will load data or code from that MBR records continuously to a particular location within the RAM. In our example 80. Then control will hand over to that part. Okay. So our next question is how to we have to design a bootstrap loader for our SIC machine. A simple bootstrap loader. Okay.